We're Group 5, and this is our presentation on vehicle delay. I'm Nyla Amer.
I'm Kayla Doshi-Batla.
I'm Pedro Nunes.
And I'm Eduardo Rodriguez.
So for our introduction, we'll talk about our objectives. Our objectives are to calculate vehicle delay by evaluating the number of stopped vehicles and the number of moving vehicles at various intervals. This was later used to determine the average control delay and the level of service. For data collection, we collected data at the eastbound direction of South Marietta Parkway and the KSU main entrance. This was collected on February 6th during the PM peak hour. A location map is included on the next slide. So again, our intersection is South Marietta Parkway at KSU West entrance. It's west of its intersection with Cobb Parkway, and we have a little zoom in to show exactly the lane geometry that we were working with. We have two lane groups. Lane group 1 was a through only lane, and lane group 2 was a through and right turn lane. And here on screen, we have our effort statements of our contributions towards this presentation.
And next, I'll talk about data collection and calculations. First, I wanted to explain how we counted the data for our 15-second intervals. So for the two videos at each 15-second interval, we paused the video and counted how many cars were stopped in each lane group. So here I put up an example at minute 21, 15 seconds, and there were 2 cars in lane group 2 and 3 cars in lane group 1. And we went ahead and put that in our Excel sheet. There's an example of that to the right. I highlighted the section where we inputted it. And for our 1-minute interval, we counted vehicles that stopped at the intersection and vehicles that went through the intersection for each lane group. And of course, I went ahead and did the map again, so you can see the through lane group number 1 and the through and to the right lane group number 2. For our calculations, I have them listed below on how we came up with our total delay, average delay per stop vehicle, average delay per approach vehicle, approximate average control delay, and percent of vehicles stopped. And next, you'll see our results. So for our through lane group and our through and right lane group, a lot of the results were fairly similar. The ones that we focused more on was the approximate average control delay and the level of service. The level of service was A for each lane group, and then the approximate average control delay was 6.77 for the through lane group and 7.25 for the through and right lane group.
In the discussion, the total volume of vehicles that approached the intersection were 950 vehicles in both lanes group. The level of service gives a letter rating intersections and tells us about the pattern and the flow in the intersection. Based on the calculation average on control delay, we determined that both lanes control are operation on the level of service A. On the video, we could usually say confirm that the level of the service was A while the recurrent traffic were good. Vehicle quickly and efficiently move through both intersections, also approach the traffic light when they turn green.
So to conclude, a level of service of A for both lane groups is tremendously beneficial given lane group number 2 serves as one of many entrances to the KSU campus. After a thorough analysis, not much can be done to the intersection to improve an already satisfying signal timing. An analysis of the next upcoming intersections would be required to be able to provide a recommendation if a shorter delay period for that intersection will be beneficial to the preceding intersections. If all preceding intersections can be improved by changing the signal timing, then we may also run the risk of impacting traffic flowing perpendicular. So there's really more to what meets the eye. And here we have our references. Thank you.
Thank you.